Hey everybody, in this video we're going to go through some more advanced probability problems. We're just going to include pretty much everything we've talked about in this course up until now, in this unit up until now. And so the first problem, we're going to roll 2 dice 3 times. And we want to know what the probability that we get a sum of 7 for the first time on the 3rd roll. So what does this mean? So let's parse this out a little bit and change the English into math. So if I'm going to get a 7 on the 3rd roll, a sum of a 7 on the 3rd roll, that means on the first roll, I'm going to get not a 7, so no 7. So I have the probability that I'm not getting a 7, and for the second roll, the probability that I'm not getting a 7, and the probability on the 3rd roll that I am getting a 7. Okay. So this is an AND problem because these 3 things have to happen in succession. And so rolling 2 dice, they're independent. I'm going to multiply these together. I want all 3 of these things to happen. I want to not get a 7 the first roll. I want to not get a 7 the second roll. And I want to get a 7 in the 3rd roll. So all of these things I want to happen. I want all of them to be true. So that's an AND problem, not one or the other. This is an AND. And so I'm going to need my table here from before. So I'm just going to put in my die table because it's going to be helpful for me. If I need to know the probability of getting a 7, it helps to know how many different ways can I get a 7. So I can get a 7, that's this whole column this whole diagonal right here. These are all 7s. So there's 1, 2, 3, 4, 5, 6 different ways to get a 7 out of 36. So the probability of getting a 7 is 6 out of 36, which means since the probability of not getting a 7 is the complement of the probability of getting a 7, that means the probability of not getting a 7 is going to be the remaining 30 out of 36. And I can reduce this if I want to, but it's fine to just leave it as is. So I want to roll a sum of 7, but only on the 3rd roll. So I'm going to do the probability of not getting a 7, no 7, times the probability of no 7, times the probability of 7. So that's going to be 30 out of 36. Another 30 out of 36, and then a 6 out of 36. So if you want, you can leave your answer just like this, because that'll show me the work that you're doing. Or if you wanted, you could multiply it out, which would mean multiplying across here and multiplying across here. But it's fine to just leave your answer like this. All right, moving on to the next one. Now we have 2 dice again, but now we are looking for the probability that we get a sum of 9 in all 3 rolls. Okay, so this word shouldn't be here. So we want to get a sum of 9 all 3 times. So it is going to be helpful again to have my table ready. That just shows me all my probabilities for rolling 2 dice. So rolling a 9 would be here, 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 and here. So there's 4 ways that I can roll a 9 out of 36. So the probability of getting a 9 is 4 out of 36. And remember, I want to roll a 9 and roll another 9 and roll another 9. So what I'm really looking for here is the probability of rolling a 9 times the probability of rolling a 9 times the probability of rolling a 9. So that's just going to be 4 out of 36 times 4 out of 36 times 4 out of 36. And again, you can just leave your answer like that. So now we want to roll 2 dice 3 times. What is the probability that we get the sum of 8 exactly 1 time in those 3 rolls? So this one is a little bit different. We want to get a sum of 8 1 time, but we don't care if it's the first example we did, we wanted it to be on the 3rd roll. Here we don't care when it happens. So this is actually going to be the probability that I get an 8 on first roll, or the probability that I get an 8 on the second roll, or the probability that I get an 8 on the 3rd roll. Now I want to make sure that in all 3 of these instances that I only get an 8 on the first roll and on the second roll and on the 3rd roll. I don't want to get the 8 more than once. I only want to get the 8 1 time. So that means it's like doing that first problem over again with the 7, except now it's with an 8, and we're going to do it 3 times. We're going to do the probability that I get an 8 just on the first roll, and then just on the second, and then just on the 3rd. So again, it's helpful to have our diagram with all our probabilities in it. We know that we can get an 8 1, 2, 3, 4, 5 different ways. So there's 5 different ways I can get an 8 out of 36. That's the probability of an 8, which means the probability that I don't get an 8 is going to be 31 out of 36. So let's take this one at a time. We want the probability that I get an 8 on the first roll, and only the first roll, or, so I'm going to add these together, the probability that I get an 8 on the second roll, and only the second roll, plus the probability that I get an 8 on the 3rd roll. So this is an OR problem, so I'm adding, but these are mutually exclusive events. I can't get an 8 and not get an 8. I can't get an 8 on the first roll and get an 8 on the second roll only at the same time. So there's not going to be anything that's in common here. So let's break down getting an 8 on the first roll. So if I get an 8 on the first roll, that means I get an 8 the first time, but then I don't get an 8 on the second and the 3rd roll. And then for the second one, that's the probability that I get no 8, and then the probability that I get an 8, and then the 3rd roll is the probability that I don't get an 8 again. And then the last scenario, the last way that I could roll exactly 1 8 is to not get an 8 on the first one, to not get an 8 on the second one, but to get an 8 on the 3rd one. So we can go ahead and add all of these together. So that means I'm going to have 5 out of 36 here, and then I'll have 31 out of 36, 31 out of 36, so I'm just filling in the numbers here that go with each probability. 31 out of 36 is no 8, no 8, and then 8. And you'll notice, since multiplication is commutative, it's basically just, it's the same thing 3 times. The order doesn't matter here when I multiply, so I could have just done 3 times 5 over 36 times 31 over 36 times 31 over 36, and it would have given me the same result.